Example 5. In this example, we're going to talk about how to take a function where the limit would not exist and use algebra to determine the limit. In this particular problem, we're going to use the product rule. So we want to determine the limit as x approaches 0 of tangent of x over x. We've looked at this graph once briefly before, but let's pull it up again. So here's the graph of tangent of x divided by x. Now if we look at this, we want to find the limit as x approaches 0. So we need to look at the y values on the graph when x gets close to 0. So we just trace the graph as x approaches 0 from both sides. And you'll notice that it looks like we get to y equals 1. So going back to this should equal 1. But what we're going to do now in this problem is sometimes you're not allowed to use your graphing calculator, and sometimes you don't know what the graph looks like. So we're going to use some algebra. This is the limit as x approaches 0 of tangent of x over x. Now if I directly substitute 0, I get 0 over 0. So we're going to do some fancy algebra now. The limit as x approaches 0. Now recall what tangent is. Tangent is sine of x over cosine x. And then you multiply that by 1 over x. Now this came from the fact that this is tangent times 1 over x. So I just broke up the tangent. Now I'm going to rewrite this in a little different order. Because it's multiplying, you can multiply in any order. So this is sine of x divided by cosine of x times x. So we get that this is now sine of x divided by x times cosine of x. So what I did here is I just reversed the order of the x and the cosine. And now I'm going to break it up a little bit. And so this is sine of x over x times 1 over cosine x. So this is still the same as our original function. And now I'm going to go ahead and I'm going to apply the limit as x approaches 0. So we know that the limit of sine of x over x, the limit as x approaches 0 of sine of x over x is equal to 1. But what I'm going to do is I'm going to use the product rule of limits to write this as two limits. And now I can use a direct substitution. So this is the limit as x approaches 0 of sine of x over x times the limit as x approaches 0 of 1 over cosine of x. So this portion of it, we know from previous examples, is 1 times 1 over cosine of 0. So this is 1 times, and cosine of 0 is 1. So then you get 1. So this means the limit as x approaches 0 of tangent of x divided by x is in fact 1. Okay, on your own, I want you to algebraically determine the limit as x approaches 0 of sine squared x divided by x. I do recommend you graph it on your calculator just to get a sense of what the number should be. Okay, so let's see what we get. So step 1 is we're going to go ahead and we're going to look at the graph. Here's the graph of sine squared x divided by x. So we want to look at what happens when x approaches 0. So we follow this graph to when x is 0. And it looks like we arrive at 0. So we should get 0 when we're done. Okay, so the trick here is we need to be able to pull out a function that we know the limit of. Well, this is sine squared of x, and we can rewrite sine squared of x as sine of x times sine of x. And then I can rewrite that as sine of x over x times just sine of x. And again, we know this limit, so we should be okay. So now we're going to use the product rule of the limits. And now we know that this first limit, the limit as x approaches 0 of sine of x over x is equal to 1 times, and now we can just plug in 0, sine of 0. So you get 1 times 0, which is 0, which is what we should have got in the first place.